This work talks about semantic segmentation, but it's different from normal approaches. We have one line to scan the images from left to right or from top to bottom, or even inversely. This approach will give benefit that use the minimum size memory so that the semantic segmentation can be applied to edge devices. It is well known that the semantic segmentation has encoding and decoding part. The bottom part read the images, then through the CNN pyramid, through many layers of latent variables, so that we can get some global information, and it is decoded to the labels. This process to semantic segment entire images is implemented patch by patch. So if you have a large images, mostly you have small objects, at the same time large global structures, you want to have a large receptive field to keep the accuracy, keep the ability to learn global structures. However, in the real case, this will increase a lot of memory. So what we are doing is to convert this network learned through patch mode to a linear scaling mode. Okay, the parameters are the same, but the structure is different. It's newly designed so that it can be applied to the images through line scanning to achieve the same accuracy. To keep a large receptive field for the accuracy to grasp the global structures, we can use a large network, large patches. At the same time, if you, for the real application, you can squeeze the network by using dropout nodes that's included channels and links in the computation to make the network smaller. Okay, if it is really resources limited case, we can reduce the images to small sizes. But in that case, although you fit into the network, the small objects will be hurt. In our case of sequential semantic segmentation, SE3 here, we use very, very small network, but it works on the same large images. The idea is to cut the images to slices so that we can cook a slice at a time. It's like cooking, but we are not doing this cooking separately on each pieces. We have a connection memories to maintain the global dependencies between slices. Okay, so eventually we will keep the accuracy same as the patch mode, but use much less memory for the edge devices. The way to achieve such a shift mode is to have the patch mode network moving on the data, moving on the images line by line. Here we have encoding and decoding part. Every time we move one line, advance one line, and produce one line labels. So we will see that in such an operations, we have a large overlapped regions between two consecutive network positions. To reduce such a redundancy, we developed the SE3 network. Eventually, it only works on final lines, but it will compute the network with the previously computed latent variables so that it will keep the globalness and at the same time reduce the memories very much.